We're here at the Seashore Trolley Museum's townhouse shop. It's a restoration facility where we restore period or historic streetcars. With me is Logan Rudolph. Logan is a student at the Baxter Academy in Portland, Maine. The Baxter Academy is a STEM charter high school, that offers a curriculum that is flexible, leaving in the junior and senior year, leaving 1 day a week to do internships or projects to give the students a feel for industry and what real work life will be like.
In the previous year, I had taken a CAD course and I realized that I wanted to look further into Solidworks and CAD as a profession. And one of the options at Baxter Academy is internships, where we can go into the workplace and experience what a career in that field would be like. Ernie had already modeled the main body of the Narcissus, but needed additional accessory pieces to be made.
So Logan worked on Fridays remotely from home and visited a couple of times. Logan worked on modeling the hinges used to attach the passenger doors to the streetcar. These hinges are interesting in that they were designed and manufactured by B.F. Foss, who at the time lived in Fairfield, Maine.
Unlike typical hinges available today, these hinges were actually adjustable and ran on ball bearings. Here's the adjustable screw with the lock screw next to it, and inside there's a cylinder holding the ball bearings. Here's one of the original passenger doors that fits the hinge that I designed. You can see here that the adjustable part of the hinge would affect the height of the door. We're down in the workshop at the number 2 end of the Narcissus, and I'll show you where the hinges fit. Right in this doorway, the hinges and doors that I showed you earlier would fit in, and millions of people have passed through these doors, and all of the parts that are currently on the Narcissus have also been modeled in CAD. Solidworks comes with a library of standard modern bolts, but Narcissus was made with these square-headed bolts. So one of my first projects was creating all of the bolts needed for the Narcissus.
So one of the challenges with trying to describe what computer modeling is people, the result is not tangible. I kind of have to be on the computer, or you see a print, an image that's generated by the computer. Sometimes those images are so real that it's hard to imagine that there wasn't a physical device actually produced along the way. Logan is going to show us a very simple set of steps that were used in the making of the hinge. Now, this isn't anywhere near as accurate or as complicated in the details of the hinge, but it'll give you an idea of how the computer model is developed, and you'll actually see something kind of come to life.
So first I'm going to draw the shape that I want to extrude, and I'll select the top plane because I'm extruding it from bottom up. Then I'm going to be creating the hinge part, so I'm going to grab this rectangle tool. So I've drawn the rectangle on the top plane, and I'm going to follow it up with a circle that is attached to one of the corners. And then I'm going to dimension the rectangle. We're going to do 1.5 inches here, and then we are going to do 1/8 of an inch here. And then after that we can begin to extrude this shape. I'm going to extrude the contours that I want, and I will extrude them 3 inches. And then I'm going to align the computer camera with this plane. I've converted this edge into a line in the sketch, and now I will put the circle that I want to extrude over it. And I'm going to be extruding the circle through all because I want it to go through the entire object. I'm going to be creating the holes where you would put the screws for the hinge. So I've created a vertical line to align 2 of the 3 circles, and then I've also created a horizontal line so that I can align the vertical line. And here I am turning them into construction geometry so that they will not cut extrude. I'm now going to make the horizontal line horizontal and the vertical line vertical. And now I am going to be setting the 3 circles. Now I can select all 3 of these circles and make sure that they are all equal by hitting the equal relation. Here I'm going to be creating a rectangle to cut off the bottom part of the hinge. I am going to cut through this plane in both directions. Now that we have these 3 circles, I am going to create a chamfer for all 3 of them. Then I'm going to make the chamfer 1/16 of an inch. And there is half of our basic hinge model. Realizing that the hole size is too big, I'm going to go back and fix it. Here I am reopening the sketch. Here I'm going to dimension them, and as you can remember from earlier, all of the holes are set to be equal, so this will affect the dimension of all of the holes. And the chamfers should adjust accordingly. And there we go. Here we are changing the material to brass to accurately fit the real-world hinge.
Very cool. Thank you. gives us the part that you've modeled, it doesn't have accurate dimensions. We could go back and fix those dimensions. It doesn't exactly represent the shape of the BF Foss hinge, but I think people can get a sense of the steps involved to do that. Seemed like it was pretty fast, but there are many techniques that needed to be learned to accomplish the full BF Foss hinge. Do we have that BF Foss hinge open right now? Or the assembly?
This is one of the parts that I made while in my internship with Ernie. This is the hinge that I created a fast model of a minute ago.
Oh, yeah.
I'm going to be hiding one of the components to show you the internals of the hinge. Here you can see the screws that I designed and the internal chamber to hold the ball bearings. And then here is the adjustable screw that changes the height of the hinge and the lock screw that sets it in place. Here I'm hiding the upper race so we can see the screw and ball bearings better. You'll notice that the wood screws aren't quite complete. This is because the threads for the wood screws often take a lot of processing power, and we can usually get away with not modeling them. When put in the final assembly with tens of thousands of parts, not having the threads and all of the screws makes a big difference and takes off a lot of the strain from the computer. Some of the challenges that I had to figure out are a lot of the dimensions are very complex, and taking something from real life and building it in Solidworks was definitely a learning experience. I had a lot of challenges. Over the course of this internship, I learned how to better model in Solidworks, and I realized that with enough work I can create almost anything that I want within Solidworks.
Pretty good.